Welcome to this Skill Builder at a Glance tutorial on chi-square. The chi-square test is a non-parametric test, meaning it doesn't rely on assumptions about normal distributions. It's designed for categorical data like colours, nationalities or handedness, where we're counting how often things occur. We typically use a chi-square test when we want to compare the frequencies we've observed in our data with the frequencies we would expect to see under a specific hypothesis. There are two main types of chi-square test, the goodness of fit test and the test of independence. The goodness of fit test is used to test whether a single categorical variable fits an expected distribution. For example, we might want to know whether 5 different bird species visit a feeder in equal proportions or whether some are more frequent than others. The second type is the chi-square test of independence. This is used to determine whether two categorical variables are related. A common example is handedness and nationality. For instance, is handedness independent of nationality? Or in other words, are Italians just as likely as Australians to be left-handed? Both types of test work by comparing observed frequencies, the counts we actually see in the data, with expected frequencies, what we'd see if the null hypothesis were true. The larger the difference between those, the larger the chi-square value will be. We then use the p-value to determine whether that difference is significant. If the p-value is less than 0.05, we usually reject the null hypothesis and conclude that the difference or association is unlikely to have happened by chance. To summarise, the chi-square test is a simple way to explore patterns and associations in categorical data. There are two main uses: to test for differences in a single variable using the goodness of fit test, and testing for associations between two variables using the test of independence. The test relies on frequency data, so counts, not measurements. And the larger the difference between observed and expected counts, the bigger the chi-square value. If the p-value is less than 0.05, we usually consider the result significant and reject the null hypothesis. For further academic skills resources or to book an appointment with an SAS advisor, please go to kent.ac.uk/SAS or email us at sas@kent.ac.uk. Thank you.